Okay, in this video we're going to have a look at vector proofs. Now this is quite a tough topic. I'm going to start this off on not the hardest vector proofs, but bear in mind it is a tough topic anyway. Grab a piece of paper, grab a pen, try and draw these diagrams down as we're going over them, have a go at working through some of them. You might have to rewind, have another go, have a little practice, see if you can sort of replicate some of the ones that I'm doing before we have a practice. But we're going to get started. I'm going to go over two, and I've got two for you to have a go at, so hopefully it's not going to take us too long for this, but it is, up there in the top sort of grade 8-9 topics. So let's have a look. We've got P is a point on AB such that A to P, P to B is 3 to 1. So obviously having a look at the diagram there, A to B, we're looking at that line. It says A to P and P to B is in the ratio 3 to 1. Now the best thing we can do is turn this into fractions. So if we think about that, that's a total of 4 parts. So that's 3/4 and 1/4. So this part of the line here is 3/4 of the line, and this part of the line here is 1/4 of the line. And we always have to be able to try and move up and down part of this line, and we're going to have a look at how to do that. So it says find the vector O to P in terms of A and B, and give your answer in its simplest form. Now this is quite a nice one. I'm starting you off hopefully quite relatively easy on this one, but A and B is already on the diagram there. Now if it wasn't, we'd probably be given these vectors and we'd have to label them on ourselves, but this has been put on for us. So find O to P. So we're trying to find out how to get from O here up to P. And I normally like to draw a little line in for that, but I'm not going to do it for this one. Okay, I'm going to think, how do I get from O to P? Now I can't move in this sort of direction, okay, at the moment. All I can do is I can move in terms of A and I can move in terms of B. So I can either go along the bottom here and then try and find a vector to move upwards this way. That's one option. Or, let's get rid of that, we could move up B this way and then try and go down to P this way. And it doesn't matter which one we choose, we've just got to think about how we're going to do that. Now in order to do that, I need to be able to move up and down the line AB. Now just personal preference here, I'm going to have a look at how can I move up from A to P. Okay, I could do it the other way around, but I'm just going to stick with doing it one way. Again, whichever way we choose to do it, that's fine, but I'm just going to have a look at this vector here from A to P. So I'm going to write that down over here, and that's the vector I'm going to try and find, A to P. Let's write it down here, A to P. That's going to allow me to move up and down part of that line. So in order to get from A to P, the first vector that I'm going to have a look at is the full length of the line. How do I get from A all the way up to B? Okay, and if I can figure that out, then I just need to be able to do 3/4 of that from A to P. And we can do that quite simply once we've worked it out, but I've got to find A to B first. So the first vector that I'm going to actually find is A to B. And when it comes to these vector questions, you're always looking at how you can move up and down the line without any vectors on. So that line A to B doesn't have any vectors on, and that's the line we're going to have to find. Now, in order to do that, to get from A to B, I can go backwards this way. So the reverse of A, which would be minus A. So let's write that in. I'd do minus A, that would move me back down A. And then I can go up through B, through positive B, so it'd be minus A plus B. Okay, now at this point it's completely up to you, but you can actually rewrite this in a different way. Just to remove having so many symbols, I can swap them over. I can have positive B minus A and just have it as B minus A. Okay, and I do tend to swap them around quite often to avoid having the symbols, but they mean exactly the same thing. Minus A plus B is the same as B minus A. So there's that little vector that allows me to get from A to B, and that's an important one. Without that vector we can't actually answer the rest of the question, so that's a very important one for us to look for, how to move up and down the unknown line. Now I don't want to go from A to B, I want to go just part of the line, 3/4 of the line from A to P. So what I can do is I can multiply this vector by 3/4, and I'm going to use that green one there that I've underlined, the B minus A. So to get from A to P, so we go. To get from A to P, we need to do 3/4 of that, so I can open it up in a bracket like this, just to make sure I times them both, and I get 3/4 of B minus A. Now I am going to expand that bracket. I could leave it like that, but it wants the vector O to P, so I want to be able to add some bits into this, but if we just expand that out, we get 3/4 B minus 3/4 of A. And that allows me to get from A to P. Now that's a very important vector there. That now allows me to move part way up the line. Now obviously the question asked me to get from O to P. So we already know how to get from O to A. That's along here. So to get from O to A, let's just start to write this down. Let's have a think. So from O to P, let's just write it down in one step. We would have to do the vector. We'd have to go from O to A. And then add to that this vector that we've got, A to P. And in total, that gets me from O to P. Now I'll just take note of this, is that I could have gone from O to B as well, that gets me up towards P, but then if I wanted to get from O to B and I wanted to go up this direction, I would have had to have worked out the vector B to P in order to move down this way. Okay, so I chose not to do that at the start. I chose to work out the vector A to P that I've got in green pointing upwards there. So I can't move up this direction, but it's okay because we've already got A to P, so all we have to do is go along that A there. So to get from O to A, so if I think about this, to get from O to A, it's the vector A. So if I write all this down, I'm going to get rid of this little bit in purple here so I can start writing it all down. To get from O to A is the vector A. I'm going to label this now O to P. That would equal A, which gets us from O to A. Add this vector from above here, which is A to P. Add 3/4 B minus 3/4 A. There we go. And if you have a look here, now we can actually join some of these up because we've got an A here, or a 1A, and minus a 3/4 A. Now, it does sometimes help with some of the harder questions to think of how many quarters that A is, just to keep it all matched, and 1A is 4/4 A. Okay, that might help to think about it, 4/4 A. That's just the same as 1, 4 divided by 4 is 1. So 4/4 take away 3/4 would leave me with 1/4 A. So let's simplify that, that's 1/4 A. There we go. And then we've still got the 3/4 B, that's remaining unchanged, so 3/4 B. So we have a 1/4 A, add 3/4 B. Now, a lot of the time, and this is a key little bit here with vectors, we normally have to factorize these vectors here. They're called resultant vectors. It's just the result of adding all these together. And normally we need to factorize this. And it is a massively key part of this topic. So I'm going to just do this up here. I'm going to write factorize. And it's very often, you can't factorize a whole number out, but you have to factorize a fraction out. And if you have a look, they both divide by a quarter. So if I wanted to factorize a quarter out, that would be 1/4. The 1/4 A divides by a quarter once, so that would be 1A. And the 3/4 B, a quarter fits into that 3 times, so it would be A plus 3B. And that would be our final answer there, 1/4 A plus 3B. Okay, well, there we go, and that is our vector to get from O to P in its simplest form. Now what we're going to have a look is something a little trickier here, where we've got to prove that piece is a straight line. So that was just like a little intro into vectors really, but the key bit there is moving up and down the line that doesn't have any vectors on, and being able to do 3/4 or 1/4 or a half of that, and just multiplying it out and being comfortable with writing these vectors as they're written. But let's have a look at another one. Okay, so looking at this question, it says B is the midpoint of AC. That's this one here, so it says that this is a midpoint. Now straight away, if you have a look on that line, look, A to B is the vector A, and if that's the midpoint of B to C, then this here on the other side has to be exactly the same, so we can label that A straight away. So that's another A. It says M is the midpoint of PB. Let's find that. That's here. M is the midpoint of PB. And if it's the midpoint, it's not in a ratio this time, but a midpoint means it's in the ratio 1:1, or 1/2, and the half here. And just also taking note of that line there, BP, you can see doesn't have any vectors on. Every other line has a vector on, but B to P or P to B, whichever way we look at it, has no vector on it. So that line there is going to be one that we're going to have to find how to move up and down. It says show that NMC is a straight line. So if I draw that in, let's have a look. NMC, quite hard here without a ruler, but NMC, there we go. That's the line there we're trying to prove is a straight line. Now when it comes to these types of questions where you've got to show it's a straight line, we just need to have a look at this green line here. So there's 3 vectors I can have a look at on this green line. I can go right from the start, from N, all the way up to C. That's a vector I can have a look at, N to C. Or I could do part of the line. I could go from N just to M. That wouldn't get me part way along the line, so I've got N to M. Or I could go from M, that line there with the cross on, up to C. So 3 possible vectors there that we could have a look at. Now when we're trying to prove something's a straight line, I only have to find 2 of these, and it tends to be that this one here is the easiest to find, the full length of the line, and I always look for that one first, then I just pick and choose between one of the other 2. And you're going to see we're going to be able to prove something's a straight line because there's going to be something that is similar within the vectors there when we actually find them. Okay, but we'll go about actually just trying to work them out first, and then we'll see at the end how it proves it's a straight line. But N to C, that's quite a nice easy one actually, because I can go from N here, I can go backwards up this 2B. So I'm going to write this down, the vector N to C. So I can go minus 2B. Let's have a look, minus 2B, because I'm going backwards through that 2B. and then I can move all the way down the line here from A to C, and that's 2 of those A's there, so plus 2A. There we go, and there's the vector N to C. And I'm just going to rub these lines out, let's get rid of those. Okay, so that's my vector there, and again I can rewrite that if I want to get rid of the symbols. I can write 2A minus 2B. Okay, so now we have the vector 2A minus B. That is from N to C. Now, that's one of our vectors done. So, let's tick that off, one of the 3. Next, let's have a look at one of the other ones. It doesn't really matter which one we pick, N to M or M to C, it doesn't really matter. Let's just go for the second one, as it's the second one that I wrote. And we just need to think how we're going to get from N to M there. Okay, so we have 2 options. Either we could go down here, and then up there, or we could go from N to A to B, and B down to M, all the way around. Now that's 3 parts there, so I'm just going to ignore that one. I'm just going to go down and up. Okay, so to get from N to P, that's okay. That's just down this little vector B here. But then I have to work out how to get from P to M. Now, in order to get from P to M, okay, this part here, I need to be able to move up the full length of the line. So I need to know what the full vector there for that line is, and that line is the vector P up to B. So I need to work out P to B now. So let's have a look at how we could go about getting P to B. Okay, and then we'll think about adding all these up together in a sec. So to get from P to B, let's write this one down. I'll write that down over here, P to B. I have to go up here to A, and then from A over here to B. So to get from P to A, let's have a look, we have to go backwards through this B, and backwards through another 2 B's. So that's going to be minus 3 B's, so minus 3B. And then plus this A up here, so plus A. So minus 3B plus A. Okay, now that gets me from P to B. Now we don't want to know P to B, do we? We want to know how to get from P to M, which is going to be half of that. Okay, so to get from P to M, I'm going to have to halve that. There we go, because M is the midpoint, we only want to go halfway up that line, half of that vector. So we just need to do what we did before. We'll stick a half outside the bracket. I'm not going to rearrange it here to make it A minus 3B. I'm just going to do it as we've done it here. So minus 3B plus A, and we're going to do half of that. Okay, so if we expand that, let's have a look. A half times minus 3. Remember, you can always think of these as fractions over 1. So a half times minus 3 is minus 3 over 2. So minus 3 over 2B plus, and a half times 1A is a half A. So plus 1/2 A. There we go. And that's our vector P to M. Now we're almost done, because if we can get from N to P, which we can, we just go down a B. Now we can get from P to M using this vector here, minus 3B plus half A. So if we have a look at this one here, let's label this up. So we're now going from N to M, the full bit there. And in order to do that, we do 1B, so B, and then add to that this vector here that we've just worked out. Okay, so we're going to bring that down here. Okay, literally the one we've just worked out. So B, and I'm going to put the half A next to it. Let's have a look. In fact, no, let's put the minus 3. So it's not going to be plus, because it's minus 3.5B. So we could put add minus 3.5B, but I'm just going to get rid of the plus and just put it in there just to avoid having extra symbols here. So it's B minus 3.5B plus a half A. There we go. Right, so again, we just need to simplify this down. We're almost done. We just need to simplify this. And if we have a think, let's have a think. The B's there in terms of halves. So 1B is 2 halves B. And 2 halves B, take away 3 halves B, is going to leave us with minus a half B. Okay, 1 take away 1.5 is minus a half. So if we work that out, we've got minus a half B plus a half A, that half A that we've got there. And that's our final vector there to match that up. Now, that means we've done N to M, so we can tick that off. Okay, now we've got 2, we just need to have a look and see if we can compare these. Now, I mentioned in the last question, it's very, very important here that we factorize these vectors and we can see if there is anything common between them. We'll have a look. So if I come back to this N to C one, the first one, if I factorize this one here, and rather than rearranging it, I'll factorize this one, I could take 2 out. And if I take 2 out, that would leave me with minus B plus A inside the bracket. Okay, and that there is going to be a really key vector, so I'm going to highlight that. 2 lots of minus B plus A. If I do the same again to this one, so if we factorize this one as well, I'll just see that was that one factorised. If we factorise this one, the only thing we can factorise out is a half, so I could take a half out. Let's have a look. So take out a half, divide the first bit by a half, we get minus b. A half divided by a half is 1, so minus 1b. And then dividing a by a half, we get plus a. There we go. And that's that vector there if we factorise it. And again, I'm going to highlight that one. And let's just write them down over here next to these vectors that I was going to work out in the first place. So for n to c, we have two lots of minus b plus a. And for n to m, the other one we worked out, we've got a half brackets minus b plus a. There we go. So if you have a look, we've obviously got this similar bracket. We've got this same vector in there, minus b plus a. Now, if we've got the same vector there, minus b plus a, it means that the lines are going in the same direction. And if they're going in the same direction and they're connected here at m, then they must be on the same straight line, because if they're going in the same direction, they're connected together at that point m, then they have to be going in the same straight line. The 2 there in n to c means that's the full length of that, so it's doing 2 lots of that vector. The half means that from n to m is half of that vector, which means if we had have worked out this line here, m to c, it would have been the other 3 halves, or the other 1.5 of that vector. Okay, so you'd get 3 halves of minus b plus a. And you could work that one out as well, but we only ever have to work 2 out. Now, that is enough to show that it's a straight line, but personally, particularly if it ever says prove or anything like that, I'd just like to write that they both share the same vector. You can say that they share different multiples of the vector. One's 2 lots of it, one's half lots of it, but I would normally put a little statement in, just pointing an arrow at those brackets and saying that they share the same vector. Okay, so obviously that is quite a tricky one. It's not some of the hardest of the vectors. Some of these new vectors seem to be very, very tough, but there's a lot going on in that question there and a lot to be thinking about. So I've got one for you to have a go at. Here it is. Okay, so we're going to go over this question, but have a go. Okay, see how many vectors you can label. It's asking you to prove that x, y, z is a straight line. So draw that straight line in. Okay, so if you sketch this diagram, draw your straight line from x, y, z, and then think about those 3 vectors there. So you've got x to z being the full line. Can you find that one out? You've got x to y, which is part of the line, quite similar to the last one we just did. And you've also got from y to z. Now you only have to find 2 of those, but if you can see how many of those you can actually find, okay? So a little bit of a hint on that one there, but have a go. The one thing that you do need to do here is also label the vectors on. It tells you what they are here. So if we start labeling those up, before you have a go, O to A, it says is A. It says O to X down here, moving from O down to X. Oh, that's not very good there. O down to X is 2B. And it says from X to B, so from X to B, this bit here is 1B. So that's everything to label on there, everything to be thinking about. So pause the video there and have a go. Okay, let's have a look at some of the answers then. So from x to z, hopefully that you've seen, that one's not too bad, okay, to get from x to z. But let's have a look. It says A is the midpoint of OZ. So if A is the midpoint, then this must also be A. And it says Y is the midpoint of AB. So AB, so hopefully you've labelled on that these are halves here. Okay, there we go, midpoint, half and half. So to get from x to z, it's not too bad. We just have to go, and I'll do this in a different colour. Let's have a look. We go up to O, and then across there from O along to Z. I can't draw that in because I've not got much space, but we can actually draw this vector. So if we draw this in, let's write this down from x to Z. That is minus 2b, moving backwards through that 2b, plus those 2a's moving along that way. Okay, so again, you could write this as 2a minus 2b, but ultimately we just want to factorise that now as well. You might have left it to the end to factorise, but you would have 2 lots of minus b plus a. There we go. So if we label that up here, we've got 2 brackets minus b plus a. There we go. Obviously you could find some of the other vectors here. You can either move from x to y or from y to z. Now we could have a look at finding all of them, but let's just have a look. Now firstly, things first, I'm gonna move this way up the line, so I need to figure out the vector b to a, and then I can do half of that. So the next one I'm going to write down is b to a. There we go. So to get from b to a, we would have to go minus 3b's up this way, plus an a. So minus 3b's plus a, minus 3b plus a. There we go. And we want to go half of that, so b to y. So b to y will be half of that. Let's write that one down, because we just want to move up to the midpoint. So half of that, so half of minus 3b plus a. And if we expand that out, what do we get? Minus 3.5b plus a half a. There we go, and there's our vector b to y. Now we can move from b to y, we can get from x to y. So let's have a look at that one. So from x to y, we can go down that b, so b, and then add in this vector here, so minus 3.5b plus the half a. And if we simplify that all down, 1b take away 3.5b, as we saw on the last one, is minus a half b. So minus a half b plus that half a. And again, we can factorise that. So if we factorise the half out, we get 1 half minus b plus a. There we go, and there's our vector. So it's 1 half minus b plus a. There you go, hopefully you see the similarity between this one and the last one, but a blank question looks a little bit different, asking you to do the same thing but worded differently with different letters, but actually look, you get the same answer for this question, so hopefully that just shows you, and hopefully you've been able to practice that and have a go. Now what you might have seen is that, and to be fair, before we move on, let's just highlight this. Look, we have the minus b plus a in both of them, so you would make the little statement there, it shares that common multiple, that common vector of minus b plus a. But if you did find y to z, which you could have done, we would do a very, very similar thing here. Look, we already have the vector for moving halfway up b to a, from b to y, and that's the same as moving from y to a. So that b to y, and let's just have a look at this in a slightly different colour, because I'm just going to go beyond this a little sec. So this vector here that we worked out, the minus 3b plus half a, if we wanted to do y to z, which was our other vector that you could have found, we would have had this vector from above, so minus 3.5b plus a half a. That'd get us from y up to a, and then we'd have an additional a here to get from a to z. So we'd add another a in. And if we combine that all together, we get minus 3.5b's, and then a half a plus 1a is 3.5a. There we go. And if you factorise that one, which we can bring up here, you can factorise 3.5 out. So you get 3.5. And then you would get minus b plus a, and again you'd have that matching bracket. So you can do all three of them work, but hopefully that just shows you there how you can actually find the other one as well. Now I've got one more question for you that's going to be a little bit different now. Obviously that one was very, very similar to the one we just did, but let's have a look at this last one. Okay, so a different question here. You can already hopefully see in that ratio it says D is the point on BC, such that B to D, D to C is in the ratio 3 to 1. So similar to that first one there, you're going to have to turn that into fractions. You've got part way up a line rather than halfway. And then it gives you some of the vectors. A to B is 3a, that's on the diagram. A to C is 2b, that again is on the diagram. And it says B to E, that big line at the top, is 3 lots of A to C. And then it says prove that ADE is a straight line. Okay, so if you want to just have a go just there, pause the video, and we're going to put a few hints on here before asking you to pause it again, but if you want no help at all, you just want to have a go and see what you get, pause the video there. Okay though, if you want some hints, here we go. So D is the point on B to C, such that B to D, D to C is in the ratio 3 to 1, so that's in quarters. So that there is 3/4, and that there is 1/4 of the line. It also wants us to find ADE is a straight line, so I'd put my little straight line in, and I need to think about those three vectors that I want to find. So you've got the full length of the line, which is A to E. You've got part of the line, the little bit down there, which is A to D. And you've got the length of the line going from D to E. So you need to find two of those vectors, okay? Up to you which two you find, but you need to find two of those. Anything else that we could have here as any hints from the question? We've got that last little bit of information that says B to E is 3 lots of A to C. Well, A to C is 2b down there on the bottom of the triangle, and 3 lots of that would be 6b. So that bit there is 6b. Okay, so there's two things that I would suggest finding first. One of them is the vector from A to E, and the other one is the vector moving along that line there, B to C, and it doesn't matter which way you go. I would maybe do C to D, I think I would find, so I would probably go from C to B, find that vector, and do 1/4 of that to find out how you get from C to D, and then I would compare those ones moving in that direction. But there you go, there's your hints. If you want to pause the video there, we'll go over the full answer in a sec. Okay, so the full answer for this, D is on the point B to C, so B to D to C is 3 to 1. We've labelled that up, so we have 3/4 and 1/4. And we've labelled everything else on the diagram, and we've got to prove that ADE is a straight line. So the full vector from A to E is quite a nice one. To get from A to E, you move up 3 A's and then along 6 B's. So that's quite nice. Let's just write that down. So it's 3A plus 6B. And in fact, let's write that down somewhere else because we want to factorise it over there. So if we write that down over here, A to E is 3A plus 6B. And if we factorise that, we can factorise 3 out, and it would leave us with A plus 2B. There you go. So we have 3 lots of A plus 2B. And there's that one. Right, so we're looking for this A plus 2B in another bracket. Now, I'll probably find both of these, but let's go for A to D to start with. So I need to find C to B. Now, to get from C to B, I just go minus 2B, so C to A, minus 2B, and then add 3 A's to that, moving from A to B. So that's how we get from C to B, and we want to do 1/4 of that to get from C to D. So from C to D, let's do 1/4 of that. So 1/4 of minus 2B plus 3A. And if we times them both by 1/4, we get minus 2/4 B, and I'm not going to write that as a half. I'm going to leave it as an amount of quarters. It might help me to combine them in a sec. But let's have a look. I've got minus 2/4 B, and then plus 3/4 A, and that's my vector there from C to D. Now obviously we want A to D, so in order to get from A to D, let's have a look. To get from A to C, we do a 2B, so we've got 2B, and we're going to add to that this other one here. Now that first piece is negative, so I'm not going to bother putting a plus, so we've got 2B, take away 2/4 B, and add to that 3/4 A. Now this is sometimes where it throws people, but 2B, I know when we did 2B take away 2/4 B, we could work that out because it's 2 take away a half, which is 1.5, but I want to leave it in terms of quarters because I'm going to have to factorise it in a sec. That's going to make it a bit easier to do that. So in terms of quarters, 2 in terms of quarters would be 8/4. 8 divided by 4 is 2, so it would be 8/4. So instead of thinking about 2B, I could write it as 8/4 B. And 8/4 B take away 2/4 B leaves you with 6/4 B. So we have 6/4 B plus 3/4 A. Again, you don't have to do this, but I just think it makes it a lot easier here to actually think about how this factorises, because now we've got both the denominators as 4, you can see that they both divide by 3/4 there. So 3/4 fits into both of them, and if we factorise that, let's see what we get. We get 3/4, and 3/4 fits into 6/4 twice, so we'd get 2B, which is what we want, it matches up there, and 3/4 into 3/4 is 1, so plus A. And again, my vector has actually come out in the opposite direction there, not opposite direction, the opposite way round, because up here it was A plus 2B, and here it's 2B plus A. It means the same thing, so we can just rewrite that as 3/4 A plus 2B. There we go. And if we label that up here, we have 3/4, really bad 3/4 there, let's try and redraw that. 3/4 A plus 2B, and there we go. And it does say prove, so we would again want to just write a little statement here just saying that they are both multiples of A plus 2B, both share the same vector there, moving in the same direction, and if they're attached at D, then they have to be on the same straight line because they are moving in the same direction, have that same attaching point there. But just obviously as a side note, we could have found D to E, so if we could do that one as well. It's a little bit more complicated on this one because it's not half and half. So from C to D is 1/4 of that, I'd have to find 3/4 of the line now, which wouldn't actually make too much hassle here, but if you did do it the other way around, it would just be at this point down here when I did C to D. Let's have a look, that one there, I would have done 3/4 of that vector. And if we work that out, let's have a look, 3/4, let's see if we can work this out to the side, running out of space here. Let's get rid of this vector A to E over here and see if we can do it here. There we go. So if I did do D to E, I would have to do 3/4 of C to B. So I would do 3/4 of minus 2B plus 3a. And then once I'd done that, I'd add in this 6b to get from b to e. So once you've expanded that, you would then add 6b's in. And if we work this out, let's have a look, what do we get? We get minus 6 quarters b plus 9 quarters a, 3 times 3 quarters, plus the 6b, and again, how many quarters is 6? That is 4 times 6, which is 24, so it'd be 24 quarters b. And if we join that all together, 24, take away the 6b at the start, leaves us with 18b. Again, not got much space here, so we'll write it over here. We've got 18 quarters b and 9 quarters a. There we go. And again, we can factorize that by 9 quarters this time. So if we take 9 quarters out, just about fit this in, we'd get 9 quarters, 2b plus a, or a plus 2b. There we go, just about fit that in. Sorry, it's quite small on the screen there, but that is just an additional step, and as you can see, you get the matching bracket no matter which way you took. Okay, so I always opt to do that sort of first part of the line rather than the second part of the line, but that's just my personal preference on how I like to do it. So, I mean, I know there's a lot going on there, particularly if you're not that comfortable with vectors. Okay, you might have found that quite daunting doing some vectors there, or it might just be a nice reminder for you if vectors is something you're quite comfortable with. It is a tough topic though, so you know, you might want to just go back, run through it all again, make some notes, keep practicing those questions and trying to get comfortable with all the different bits of maths going on in this question here. But that's vectors. I will have a look at some of the harder ones soon, because some of the ones that have been coming out quite recently are very nasty, but it's just about thinking on a question like this, how can you find bits of each question that you can get marks on. One of those tends to be finding the full length of the line. That's always a good one, it's never too nasty to find. And the other one is finding a vector of a line that has no vectors on it. So in this case that was C to B, or you could have gone from B to C, but either way you want to have a look at what line has no vectors on and see if you can create a vector for that. But that's the end of the video. Again, if you found that useful, please like, please comment, please subscribe, and I will see you for the next one.